In this question, we're given a scatter plot showing some data which relates a relationship between fuel consumption and engine size of cars, where all the points are plotted from various tests that they've done. They've then plotted a line of best fit on the graph, and that's the focus for the question here. The question's looking at, for the first part, finding the equation of the line of best fit in terms of F and E, and then the second part is using that line to make an estimation of data. So the first part is looking at the straight line. So we want a line of best fit. Now, when it comes to a straight line, we need one of two sets of data to be able to calculate the equation of that line. We either need 2 points on the line, or we need a point on the line and the y-intercept. Now, this one doesn't go as far as the y-axis, so we know we're not getting the y-intercept. So we need 2 points which lie on the line. Well, we've got them. So we've got 1 point there and 1 point there. We just need the coordinates of them. So the coordinate at this point here, we go along 3.5 and we go up 8. So that coordinate is at 3.5, 8. This one here, we've gone along 1.5 and up 14. So the coordinate at that point is 1.5, 14. So we've got the information we need. We can then calculate the equation of our line from that. Now remember, the equation of the line is normally y equals mx plus c. But in this case, we're using different letters. We're using an E and we're using an F. So in this equation, we replace the y with the F and we replace the x with the E. Now, whether we do that at the start or whether we do our calculation as normal using y and x and then replace them at the end, that's neither here nor there. The key thing is your final answer must be in terms of these two variables. Now, to get this equation, we need two things. We need the gradient and we need the y-intercept. Well, using the 2 points, calculating the gradient is fairly straightforward. We use our standard formula, m equals y1 minus y2 over x1 minus x2. Sometimes you see it written the other way, so y2 minus y1 over x2 minus x1. Again, both versions are valid. So you pick your 2 points, you assign them the bits here, and then you have a crack at it from there. So x1, y1, I'm going to make the 3.5 and 8. x2, y2, I'm going to make the 1.5 and the 14. So y1 minus y2 is 8 take away 14 over x1 minus x2, 3.5 take away 1.5. So 8 minus 14 is negative 6. 3.5 take away 1.5 is 2. So negative 6 over 2 gives me a gradient of negative 3 from a line. What we can then do is one of two ways of calculating this. We could put the gradient back into here, substitute a point in, and then find our c from that. Or we can use a version of the formula, y minus b equals m bracket x minus a, where the a and the b come from just one of the 2 points. Either version is valid, either version should get you the same answer. So if I was to stick with this on the y minus b equals m bracket x minus a, I would take the a and the b from one of the points. So in this case, let's take the 3.5, 8. So I'd say y minus b, the b comes from the y element of the point, so I'd have y minus 8 equals m, so negative 3, bracket x minus the x element of the point, which is 3.5. We then multiply out the brackets, move everything about and get it into this form, the y equals mx plus c. So I'd have y minus 8 equals negative 3x. I'd then have negative 3 times negative 3.5, so plus 10.5, given by this. We then shift it about and I get y equals negative 3x plus 18.5. Now we've got it here, but it's still in terms of y and x, so we have to put it in terms of the variables we want. So the e is the x-axis, the f is the y-axis. What we then do is we say fine, so what that means is that f equals negative 3e plus 18.5. That is the only way we will get that final mark. It's a 3-mark question, 1 for the gradient, 1 for substituting in, and 1 for the final answer, but it must be in terms of f and e. Second part, use the equation from part A to estimate how many kilometers per litre he should expect to get. So, what we need to do is figure out what part of the equation that we need to know, substitute in, and then see how we go. Now for this, we're told that Amir's car has an engine size of 1.1. Now engine size is the x-axis, so that's the E. So for this one, we know that E is equal to 1.1. So all we do is substitute into here and then find out what F is. So in this case, we know then that F is equal to negative 3 times 1.1 plus the 18.5. Do a bit of calculation with it. Negative 3 times 1.1 is negative 3.3. Add it on to the 18. 18 minus 3.3 gives you 15.2. But 15.2 what? We've got to think of it in terms of the question that we've been given. We know that it's here, it's kilometres per litre. So what we need to say is it's 15.2 kilometres per litre. Put it back into the context of the question with the right units. So 15.2 kilometres per litre. Now this one here, this last part, is quite simply a 1 mark point. But you only get the 1 mark if you put the units here. Now I've put kilometres per litre here. If you'd written it shorthand as km/L or kml to the negative 1, one of those variations, that would be perfectly fine as well. It would save you the scrawly handline like I've got here. So the key thing for this is we have to be able to do it, but we have to be able to put it in the context of the question. Working as we know with the y and the x is fine, but make sure you do this at the end. You have to have it in the right context for the question, and then when you do the second part of it, which is something that comes as standard, you then have to make sure again you stick to the context, particularly with things like units.